Hi guys, so we're back with another chapter for class 6 and the chapter's name is Physical Quantities and Measurement. So before we get into the chapter, let's talk about measurement. We humans, we have this inert urge to measure everything. You know, we want to know the distance from this place to that place. We want to know how thick something is. We want to know how heavy it is. And there's so many things, like they always look at it and they need to measure. And our measuring ways are totally different. You know, when we were kids, we used a hand span, okay, from the tip of one finger to the tip of your thumb. Okay, that was a hand span. Then the tip of the finger till the elbow, that was cubit. And we used our feet to measure, you know, how many steps it was. We have been measuring things ever since we were kids. Okay, because measuring is there with us. Even when we were younger, you know, most of you might have done that. Your parents might have asked you, how much do you love me? And you might have been very cute about it and they would have said, this much. Right? Why do we do that? It's because we need to quantify things. We need to know the amount of things. We need to determine how long something is. Okay, the distance between point A to point B, how long is it? Okay, we need to determine how heavy it is. We need to determine how much something is there. Okay, so we have been measuring things ever since we were kids. So let's look at the definition of measurement. The definition of measurement is, it is the act of determining the size, that is length, area, volume, and other things, mass, degree of hotness, coldness of an object, whether the object is hot or cold. When it is hot, how hot is it? If it is cold, how cold it is. Amount of quantity is like basically how many something is, some substance or object or whatever the case, how many of it is there. Time of an activity using specific devices, like for example, how long does it take for me to do something? Like running around the ground, how long does it take? We have a stopwatch for that, right? And other things. And we could get into details about these later slides. Measurement can only be done on physical quantities. Okay? Physical quantities are basically the quantities that can be measured, and measurement can only be done in the physical quantities. Please remember that. Now, let's look at the units of measurement. Okay? There are, as you can see, 4 different systems of measurement. There are CGS, MKS, FPS, and SI. CGS stands for centimeter, gram, and second. These are for length, mass, and time. MKS stands for meter, kilogram, and second, MKS. And FPS is not first person shooting, it is foot, pound, and second. Okay, and SI is meter, kilogram, and second. Why do we have these many? Okay, this was much more recent compared to these 3. These 3 were already there. Different countries, they are still using it. For example, US is still using this one. Okay, and other countries, they're still using this. The problem was, imagine a scenario. So you measure something. Okay, like let's say a distance, how long something is. Okay, so you measure it using your hand span. Good. So you know, okay, fine. 1, 2 hand spans. Good. But your friend measures it in 1 cubit, that is like from this till this. Okay, and he's like, okay, so it's 1 cubit. Now, when you do the calculations, are you guys going to come up with the same kind of answer? No, because the units that you're using for measuring are different. One is using hand span, another one is using cubit. Similarly, if you check, in this 3-foot length, CGS system uses centimeter. In case system uses meter, FPS system uses foot. Now the measurement is all confusing. CGS uses gram, NKS uses kilogram, and FPS uses pound for mass. And again, the calculation is very confusing. So what happened was, our second was same for everybody. So what happened was, people, they came together, and a lot of learned people, all the scientists and people who are doing research in this field, and they came together and they decided, okay, no, we need to have a standard system, okay, which is used internationally. Okay, every country should adapt to this, so that the studies, research done in one country and the units used out there can be understood by other country scientists, researchers from other country. There should not be any problem in communicating the research data. Okay, so for that they came up with the SI system. Okay, International System of Units, that is meter, kilogram, and second. For length, we use meter. For mass, we use kilogram, and for time, we use second. And this is your SI system, and this is the system that we will be using. You just need to know about there are other systems too, but this is the system that we are using. Now let's look at SI system. SI system, or International System of Units, is basically, like I've already talked about, is a system of units which is used by many people around the world. Okay, so it's derived from a French word, and here are some fundamental units. Fundamental units are length, mass, time, electric current, temperatures, hotness and coldness of the body. Mole is something new in this thing, and luminous intensity. These are the things out there. We'll study about a few of this in this chapter. I'll just introduce you to these in this chapter, and we'll study in detail about all of these in later classes. So once again, let's look at length. For length, it's meter. For mass, it is kilogram. Time is second. Electric current is ampere. Temperature is Kelvin. Amount of substance is mole. And luminous intensity is candela. Meter is written as M. Kilogram is written as kg, small letters. Second is written as S, or some people write it as SEC. Ampere is capital A, Kelvin is capital K, mole is MOL, and candela is C. Okay, so these are your units, SI units. Based on reduced syllabus from the ICSE board, we just have to study length, mass, and time. But I've introduced area and temperature for you, because you need this for higher classes, and you need to know this now. So before we get into any of the fundamental units, let's look at multiples and submultiples of unit. These are for your mathematical calculations that you have to do. Okay? So multiples is basically anything more than 10. Anything that is 10 or more than 10 is multiple. Okay? And whenever it is 10 or more than 10, we add a prefix. So our prefixes are mega for 10 lakhs, kilo for 1000, hecto for 100, and deca for DA, that is 10. Okay, so if I was to write meter is 1, decameter would be 10 meter. A hectometer would be 100 meter. Kilometer would be 1000 meter, and megameter would be 10 lakhs meter. Okay. Now we move on to submultiples. Submultiples means anything that is less than 1. Okay. For example, deci is 0.1. Okay. Centi is 0.01. Milli is 0.001. Micro is 0.5 zeros and then 1. Okay, so that's 0, 0, 0, 0, 0, 1. So when you put centi in front of the meter, okay, that is cm, so it will be 0.01. 0.01 meter. 1 centimeter is 0.01 meter. Millimeter is 1 millimeter is equal to 1 millimeter is equal to 0.001 meter. Okay, so that is how you use the prefixes and the symbols for your multiples and submultiples for the values. Now, let's move on to length and measurement of length. Length is basically distance between one point to the other point, from point A to point B. Okay, that is basically your length, your breadth, your width, or height. Okay, so that is your distance. So how do we measure distance? Normally we measure distance by ruler or inch tape. We normally out here locally we call it inchy tape. And other devices are screw gauze and vernier caliper. This is how they look. These are used for very small, very tiny distances. Okay, you will study about these in higher classes, so I'm not going to go in details about these. But rulers and inch tape, we have seen it and we have used it, and ruler we use it every day. So the definition of the length is defined as the distance between 2 points, which I've already discussed. Now let's move on to the units of length. Units of length are meter, that's your SI unit, kilometer, centimeter and millimeter. So the symbol of meter is M. The first one always that I'm using is the SI unit. Okay, so meter is your SI unit, M, kilometer is km, centimeter cm and millimeter mm. We have already discussed about this. And go to page number 21 and there is a table 2.4. Okay, please go through that table, it is very important, and if you want you can copy that table in your notebook. Now let's move on to area. Okay, area is basically the surface covered by an object, or the region covered by an object. Okay, so the units of area are square meter, we write it as meter to the power 2, square kilometer, that is km to the power 2, and square centimeter, cm to the power 2, millimeter, mm to the power 2. Okay, these are area units. Now let's look at how do we calculate area. So for calculating area of regular shapes, that is your square, circle, rectangle and triangle and other shapes are also there. But for now, in your class, we just need to know these 4 shapes. And for measuring the area of a square is side, that's we have taken it as A side into side. That is A into A, we write it as A square. And that is how we get your area of a square. For a circle, it is pi r square. R is distance from the center till the edge, that is known as radius. So pi r square. For rectangle, it is length into breadth. Length, I've written it as L, breadth as B. So L into B, you get your area for rectangle. And for triangle, you have half into the base into the height. Okay. So from the base, you make a perpendicular line to the top, and that is your height. So let's look at how you calculate. Here we have a square. Okay, let's say the side A. Okay, we take it as an A, and the distance A is, let's say, 2 centimeter. Okay, so A is 2 centimeter. So when we calculate the area of the square, we do A into A, that is 2 centimeter into 2 centimeter, and we get it as 4 centimeter square. Okay, so that is how you get the area of a square. All sides are equal in a square. That's why we take one side as A, and all sides also become A. Okay, that is how we calculate the area of a square. Now finding the area of a rectangle. In a rectangle, the longer side we take it as L and the shorter one we take it as B. L stands for your length, B is your breadth. Okay, so for area of a rectangle it's L into B, and let's say your length is 3 centimeter and your breadth is 2 centimeter. Okay, so we take it as 3 centimeter into 2 centimeter, which becomes 6 centimeter square, and that is how you find the area of the rectangle. Now let's find the area of a circle. How do you find the area of a circle? So we talked about for finding the area of a circle, the formula was pi r square. Okay, and we need to find the radius, that is r. Radius is the distance from the center till the edge, that is your r. Okay, so let's say the r is 7 centimeter. Okay, let's say r is 7 centimeter. So now for the area of circle, it is pi r square. Value of pi is 22 by 7 into r square is 7 into 7. You cancel 7s. Okay, then 7 into 22 is 154 centimeter square. Okay, so that is the area of a circle with the radius 7 centimeter. Just look at it. So the radius is from the distance from the center to the edge of the circle, that is a r. We take the radius to be 7 centimeter, and for the formula for the area of circle is pi r square. The value of pi is 22 by 7. Okay, and we multiply the radius twice because it is r square. You calculate and you get the answer. And that is how you calculate the area of a circle. Now let's look at how we find the area of a triangle. For finding the area of a triangle, okay, we need to know the base. This is the base. Okay, we're taking this as the base. That will be B. Okay, so the height is perpendicular to the base, and this is your height. And for the area, we already have the formula, that is half into base into height. Now let's take h as 5 centimeter and b as 6 centimeter. Okay, so the base is 6 centimeter and the height is 5 centimeter. So let's calculate it. Half into 6 into 5 cancels 3 5 is 15. So the answer is 15 centimeter square. Okay, so that is how you calculate the area of a triangle. So we have figured out how to calculate the area of regular objects using the length and the breadth. Okay, using the formula basically. Now let's figure out how to measure an area of an object or area of a shape using a graph. Here we have a square and a rectangle on the graph paper. Okay, imagine that each square has the side as 1 centimeter. Okay, so each side is 1 centimeter. So the area of the box will be 1 centimeter square. Okay, just remember that each box has an area of 1 centimeter square. For calculating the area of a rectangle by using a graph, what do we do is, it's very simple. We just count the number of boxes. We just count how many boxes are there.
So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 boxes out there, and 1, 2, 3, 4, 5. When you multiply 10 by 5, you get 50, and the area of this rectangle is going to be 50 centimeter square. Why? Because each box, the area of each box is 1 centimeter square. That's why the area of the rectangle out here will be 50 centimeters square. How we get 50? By counting the number of boxes. What we did, we counted out here. This row was 10 boxes. In this first column, it was 5 boxes. 5 into 10 is 50. Okay. And for finding out the area, for calculating the area of a square, we do the same thing. Again, we count the number of boxes. Out here, 1, 2, 3, 4, 5. And the column 1, 2, 3, 4, 5. 5 into 5 is 25. So the area of this square is 25 centimeter square. Sometimes the side of a small box, okay, just looking at a small box, sometimes the side will be 2 centimeters in some graphs, and in some graphs it will be 1 centimeter. So please check it carefully. If it is 1 centimeter, the area of the box is going to be 1 centimeter square. If it's 2 centimeter, then the area of the box is going to be 4 centimeter square. Why? 2 into 2 is 4. Okay? So just remember that. Now let's move on to mass and measurement of mass. What is mass? Mass is basically the quantity or amount of something. Okay? And the definition is, it is amount of matter present in it. Okay? It is substance or object, anything. So the units of mass are kilogram, that is your SI unit, gram and milligram. Kilogram you write it as kg, gram you write it as g, and milligram mg. Okay, all small letters. These are the instruments that we use to measure mass.
Hey guys, the video that I had recorded got deleted, and what I'm going to do now is I'm going to put on the slides and I'll do a voiceover. So the topic that we're going to continue with is the instruments to measure mass. The first one we have out here is a beam balance. I bet you have seen a version of this, the handheld one, and if you have seen it, then you know how it works. It's basically you put some stuffs on one side and measured weights on the other side, and then you try to balance it out to figure out what is the mass of the stuff that you wanted measured. And this one is a digital machine. Again, most of you might have seen it. Many of the shops out here in Kalimpong, mostly the grocery shops, have it. What you do is you put some stuffs, whatever you wanted measured, on this plate, and then it'll give you a digital reading. And this third one, this particular one, I can't seem to recall the name of this thing. So I need your help. What you do is figure out what this is called and what do we use it for, and text me. Let's see how many of you can correctly figure out what this is called and how it is used, and how quickly can you answer that. Now we move on to measurement of time. Let's understand what is time. According to definition, a particular moment in a day is called an instance of time, a moment, an event, an activity. And when you measure these moments, how long these moments take, okay, the duration of these moments is your time period. And we calculate time period, an action, okay, when it takes place, the beginning of an action, the end of an action, when you started running till the point you stopped running, how much time did it take for you to run, you know. So that is your time period. And how do we calculate? We calculate using like stopwatch and other stuff, right? Anyways, what are the units of time? First one is the second, the SI unit, and then you have minutes and hour. Sometimes people write second as S, some people write it as SEC, that's fine. Some people write minutes as M, some write it as MIN. Both is correct. Again, for R, most people write it as H, some people write it as HR. Again, both of them are correct. And I think most of you already know 60 seconds make 1 minute, and 60 minutes make 1 hour, and 24 hour makes a day, 7 days makes a week, 4 weeks makes a month, and 12 months make a year. On page number 26, you'll find the relationship of time measuring units. Please go through it, it's important. And if you want, you may copy it to your notebook. Now we move on to measurement of temperature. What is temperature? Basically, temperature is just the degree of hotness or coldness of a body. What it means is temperature tells us whether a body is hot or cold, and if it is hot, how hot it is, and if it is cold, how cold it is. Okay, and to measure temperature, we use this instrument called thermometer. There are different types of thermometers. First one is your Celsius thermometer. It ranges from 0 degrees Celsius to 100 degrees Celsius. Second one is a Fahrenheit thermometer. It ranges from 32 degree Fahrenheit to 212 degree Fahrenheit. It has 180 small divisions. And a digital thermometer, which doesn't have a range because it varies from digital thermometer to digital thermometer again. So what it does is just put it in and tell you a digital reading of the temperature. Clinical thermometer is what the doctors use. It ranges from 35 degrees Celsius to 42 degrees Celsius, or 90 degree Fahrenheit to 110 degree Fahrenheit. And that's the range of a human body's temperature. Okay, if it goes below 35 degrees Celsius or 90 degree Fahrenheit, then you might get into hypothermia. And if it goes beyond 42 degrees Celsius or 110 degrees Fahrenheit, it means you've got very, very high fever and you're at the risk of melting your brain. Next one is a laboratory thermometer. This is used for experiments, and when you're doing experiments, you need a larger range, slightly larger range than your Celsius thermometer. Celsius thermometer is based on the boiling point of water, freezing point and boiling point of water. But for lab thermometer, what you need slightly higher range of temperatures. So you start from minus 10 degrees Celsius to minus 210 degrees Celsius. And lastly, the maximum and minimum thermometer. It is used for measuring the temperature of the day. Okay, it ranges from negative 30 degrees Celsius to 50 degrees Celsius. Okay, so now let's move on to units of temperature. There are three major units of temperature that we extensively use: Kelvin, a symbol capital K, it's a SI unit; Celsius, degree capital C, symbol; Fahrenheit, degree F, that is a symbol. And for all of these, the symbols are in capital letter because the symbols are based on the person's name. Okay, it is derived from a person's name. So it is always in capital letter. And Celsius and Fahrenheit both has degree, but K does not have degree. Kelvin has no degree, and we don't say degree Kelvin, we don't write degree Kelvin. Okay, just remember that. But for Celsius and Fahrenheit, we always say and write degree Celsius or degree Fahrenheit. Now, the relationship between these units: degree Celsius is equal to 5.9 into degree Fahrenheit. You just put in the value minus 32 and then you do it. Second one is for converting degree Celsius to degree Fahrenheit. And the last one is for converting Kelvin to degree Celsius or degree. For converting from degree Celsius to Kelvin, what you do is you just take 273 on the other side, and it will be degree Celsius is equal to K minus 273. Thank you for watching the video, and if there is any question, please contact me. And all these notes, you can just find it in the website and you can download it from there.